A very good morning to one and all. Myself S.S. Jugade, and our today's topic is CNC feedback system. A CNC system requires motor drive to control both the position and the velocity of the machine axis. Each machine axis must be driven by separately and follow the command. Each machine axis is driven separately and it follows the command signal generated by numerically controlled machine. There are two ways to activate the servo drives: the open loop system and the closed loop system. So what is the open loop system? As a figure indicates, this is the CNC controller, and the command to the table, feed, axis, depth of cut are coming from this particular CNC controller. So a programmed instruction are fed into the controller. All the program instructions are fed into it. Through an input device, these instructions are then converted into electrical pulses or signals by the controller and sent to the servo amplifier to energize the servo motors. The cumulative number of electrical pulses determines the distance each servo drive will move, and the pulse frequency determines the velocity. The prime drawback of the open loop system is that there is no feedback system to check whether the program position and the velocity has been achieved. The next, this open loop system is also called as a one-way communication to the machine. Next, the closed loop feedback control system. As indicates, there are two lines. One is input and second red color is output. In the control loop feedback system, closed loop feedback system, to monitor the actual output and correct, it will monitor the actual output and correct any discrepancy from the programmed input. The feedback system could be either analog or digital. The analog system measures the variation of physical variables such as position, velocity in terms of voltage levels. Digital system monitor the output variations by means of electrical pulses. So closed loop system is a two-way communication system in which we provide the input, and for the position velocity sensor we also get the output. So this is a closed loop system. So generally in any CNC machine, closed loop system are used because it gives the proper feedback to the controller. Variable factors affecting the CNC feedback system. There are a number of factors which affects that particular factors affect the CNC feedback system. Lead screw, number one is lead screw non-linearity. If this will give an error in the linear location of the ball nut and the stage and workpiece attached to it. If lead screw has non-linearity, then it will definitely affect on the distance travel by this particular workpiece attached to it. So next is static deflection. If the spindle weight is not somehow counterbalanced, the lead screw will stretch due to the elastic strain developed due to this spindle weight. Since static deflection also affect the CNC feedback system. Tool wear. As the tool edges wears, it is shortened and it will result in larger than the commanded workpiece dimensions. Suppose we give the depth of 5 mm and due to the wear of 0.5 mm tool wear, it will actually go up to the 5.5 mm or 4.5 mm. So tool wear affects. If the operation is turning, the shaft will be larger in diameter. Next is axis orthogonality. It is assumed that the right angles are present and are maintained throughout all operation procedures. For machining or milling, perpendicular vertical milling, if we not maintain the axis orthogonality, it will result in taper. So because the axis motions are kinematically coupled as opposite to the physical coupled, errors will be there, and if the axes are not perfectly orthogonal. That is, when the axis is not perfectly orthogonal, error is definitely there. Next is resolution. Resolution is the smallest movable or readable increment of a machine tool or instrument has. All movements or readings are made up of integer multiples of the basic resolution. A machine tool with feedback such as an encoder is also limited by the resolution of the encoder. In addition to the resolution of the movement, when these two resolutions are coupled, errors will be present. So basically, what are the feedback devices are used in feedback system, CNC feedback system? Feedback devices are mandatory part in a closed loop system, because we already discussed a closed loop system is used, and typically found in a servo motor applications. In motion control, feedback devices are used to get the position or velocity information from the motor or machine. Generally, this particular advanced technology built up over here, half or more than half part is a motor part, and remaining part is a feedback device. So in any CNC machine, feedback can be accomplished in a two ways. Number one, as a linear scale, and number two, as a encoders. So what is linear scale? It measures the absolute and exact position of the slide directly. It measures absolute and exact position, both over here. Look at this. It is a graduated scale made up of either glass or stainless steel, along with the measuring surface and scanning unit. This is the measuring scale or monitor scale. This is a PCB with infrared sensor. This is diode. This is light emitting diode. So PCB with light emitting diode. This is the scale. So when there is a fully alignment, you got the exact lines. If you got the partially aligned, that get somewhat blur, and in case of misalignment, you will not observe proper lines. So this is the linear scale, is another feedback device. Next is encoders. These are the another feedback devices. An encoder is a sensor of mechanical motion that generates digital signals in response to the motion. Encoder is a form encoder generally develops a digital signal. As an electromechanical device, an encoder is able to provide motion control system users with information concerning position, velocity and direction. An encoder is a sensing device that provides feedback from the physical world. It converts the motion to an electrical signal, which can be read by some type of control device, such as counter of PLC. So what are the types of encoders? There are two types of encoders. Number one, linear encoder. Second is rotary encoder. A linear encoder responds to a motion along a path, while rotary encoder responds to a rotational motion. Hence, linear itself indicate its give response to the linearity, and it gives to the rotary gives to the response to the angular motion. And encoder is generally categorized by its output. An incremental encoders generates a train of pulses which can be used as to determine the position and speed. An absolute encoder generates unique bit of configurations to track the positions directly. So number one, linear transducers. A linear transducer are the devices mounted on the machine table, which is mounted on the machine table to measure the actual displacement of the slide in such a way that backlash of screws, motors, etc. would not cause any error in the feedback data. Linear transducer is a type of position sensor which is used to measure the movement in linear fashion. They do this by converting the linear displacement into the electrical signals proportional to the displacement they are making. So these are usable by machines of different linear transducers will be able to measure the different movements. So as per the machine movements, they measure the linearity which generates the transducer which generates the signal and measure. Second is rotary encoders. So a device to measure the angular displacement. It cannot be measure linear displacement directly, so that error may occur due to the backlash of the screw and motor, etc. So what is the exact working principle of this particular rotary transducers? Light source is here, which is in front of encoder disc. There are encoder disc is situated on the shaft rotation to be measured, whose rotation is to be measured. So on this encoder disc slots are created. So whenever light source is passing through the slots, it will measure the signals. When there is a disc come in front of this particular light source, it will not generate the signal. So it generates a single phase as per time photocell. It will generate a pulses over here. So nearer the signal, there will be a fast forward of this particular shaft. In detail we have discussed over here. A rotary encoder, also called a shaft encoder, is an electromechanical device that converts the angular position of motion of shaft or axle to analog or digital output signals. There are two main types of rotary encoders, absolute and incremental. So what is absolute and what is incremental, we can see over here. So first is we can see the incremental encoder. You can see this is an animation. You can measure the different angles up to the 360. So what are the inside of this particular encoder, we have to see. There is a scanning unit, counter. This is the shaft whose rotation is to be measured. This is a continuous disc, and this is the sensor. This is a sensing unit in front which can sense the signal like this 29, 30, 40, etc, etc. This particular signals passes through this particular disc, and we can generate track A and track B signals over here. And as per this particular generate, the counter counts. Look at this: 8, 6, this is 5, this particular 4, this is when this is a 3. So track A and B are generated pulses over here, and as per this particular track we can count. Remember, it is a incremental encoder, so clockwise rotation denotes the incremental slots, or anti-clockwise denotes the decremental counter number over here. So this is called as a generally a encoder. Second is a rotary encoder. Then how it will be work? Look at this. Rotary encoder is used to measure the angle of rotation. Look at this. The shaft whose angle is to be measured is over here, on which disc is mounted. You can see this is the shaft whose angle is to be measured. This is the sensor. You can generate the binary code over here. So any start or stop, which results in rotation of that particular motion. The scanning unit, this is the scanning unit, this is the disc. So disc for counting the revolutions are attached over here. Main disc is over here, and for reduction gearbox is used for measuring the exact angle over here. Look at this. This is a rotary encoder. In the video you can see the rotary encoder for angle measuring device is marked as a 3 binary bit for angle measuring instrument. The inner ring corresponds to the contact one in the table. Look at this, one in the table. This is inner ring. Black sectors are on 0 degrees on the right hand side. These are the black sectors are the right hand side, with the angle increasing in the clockwise direction for this particular rotary. For absolute, you know that this particular rotary encoder angle measuring device is marked in 3 binary reflected gray code. The inner ring is correspond to the contact 1. This inner ring corresponds to the contact 1. This. So the encoder disc in an actual system, the encoder disc is mounted on the lead screw. Look at this lead screw. This lead screw, and encoder is mounted on this particular, because we have to measure the revolutions of lead screw and angular movement provided by this particular lead screw. So what will happen? Sensor element sense the exact position of lead screw on rotation or linear motion, and it will give the feedback to the machine control unit, and as per that feedback, machine control unit operates the servo motor. This is for linear, this is for rotary, and this is for linear. For linear, optical scale is there, and this particular scale we get feedback from this particular optical scale, and which provided to the machine control unit, and machine control unit can work as per this particular feedback provided by optical scale. Next thing is the analyzing the position of NC system. Precision in NC positioning, the 3 major criteria is there: control, resolution, accuracy, and repeatability. So what is the control resolution? It is the distance separating the 2 adjacent addressable points in the axis movement, where the accuracy is closeness to the true value, means maximum possibility that can occur between the desired target point and the actual target point or taken by the system. Repeatability, it is defined as a plus or minus 3 sigma of the mechanical error distribution associated with the axis. This is the general diagram in which you clear the control resolution. Accuracy, look at this accuracy, we have to reach the desired position over here, we got here. So difference between this particular is error is nothing but accuracy in terms of accuracy. This is the 3 plus or minus sigma limit. This is the addressable point where you can give the address. There are another feedback devices which is attached to the CNC control system, that is velocity feedback device. The actual speed of the motor can be measured in terms of voltage generated from the tachometer mounted at the end of the motor shaft. Look at this. Actual speed of the motor is measured by using measured in terms of voltage generated from this particular tachometer, which is mounted at the end of motor shaft. The voltage generated by the DC tachometer is compared with the command voltage corresponding to the desired speed. The difference between the voltage is used to actuate the motor to eliminate the error. So what are the different display units are used in CNC control system for the feedback control? The display units are interference between the machine and the operator. Position of the machine, it check the position of the machine and slide. It gives the spindle RPM, it gives the feed rate, it gives the part programs, and display unit also useful for the graphic simulation of the tool path. So what are the interpolation methods used? In case of interpolation, there are 4 interpolation are used, that is linear interpolation, circular interpolation, helical interpolation, and parabolic or cubic interpolation. Linear interpolation belongs to the straight line, that is straight line between the 2 points in a space. Circular interpolation defined as the starting point and end point of the center of the radius and the direction. Helical interpolation belongs to the circular plus linear motion, where the parabolic or cubic interpolation belongs to the free-form curves using a higher order equations. So what is the linear evolution? Look at this. This is original counter, red mark is original counter, linear tool path, it will go like this, P1 to P2 to P3, and there is a difference between these two is called as a original counter. This is circular interpolation. You can see the axis of spindle moves in a series of straight line chord segment to the generate a circular motion. More segment, better will be the approximation. absolute and incremental positioning. An absolute movement moves to a coordinate based on your 0 point. An incremental movement moves a distance based on your current position. An incremental movement does not take your 0 point into the consideration. Means what? Look at this. For absolute, what is meant by absolute and what is meant by incremental position? The work head is presently at 2020. Look at this, 20x and 20y. So it must be 2020 and it is moved to a 40-50. Suppose it is moved. Suppose it is at the starting position. It is x and y coordinates are 20x and 20y. Suppose it moves from here, from 2020 to 40-50. That is your 40-50 is here. That is x and y coordinates. X coordinate 40 and y coordinate 50. In case of absolute positioning, the move is specified by x40 and y50. But in case of incremental, this is absolute. Absolute is called as starting from the 0, considering from the 0, that is 40 and 50. But in case of incremental, it will be considered from its last point, that is from 2020, and it will be measured like x20, like 20 plus 20 is equal to 40, so x20, and 20 plus 30 is equal to 50, so y is equal to 30. So x20 and y30 considered for the incremental position. So these are the general feedback system used for the CNC machine control unit. Thank you very much.